Welcome all to Excode week 2. Hopefully. Oh, thank you. Appreciate it. Hopefully, a bit the same fun as last week with a bit less technical issues and a better working mic. So this week, the title is Decoding Programming. We're going to look at the following 3 main concepts: variables, data types, data conversions, and then look at programs using those concepts. As every week, it's 30 minutes of lecture, a small activity at the end here in the lecture, and then in the workshop rooms, and you can go with your workshop leaders. Administratively, as we had some issues last week, we're going to have all of you counted as present last week. So at the end, I'm also going to give you the code to check in as last week. So if you were missing or anything, you can check in. It's not a problem, as we know, especially for the people online, that some of you have not been able to check in automatically. So let's get started. I'm going to also give some more administrative information at the end if you have any issue with your check-in on the platform. The first topic of today is variables. And variables is one of the core concepts in programming languages. So much so that you don't define a programming language without a variable. This is a core defining principle of those. And to explain variables, I'm going to do a magic trick. I'm going to ask Arya if you can come on stage. I'm going to take an Excode branded box that Arya designed for us.
Thank you. I worked hard on it.
And the way it's going to work is we're going to explain what a variable is for a really simple magic trick. So can you see this is a beautiful coding for beginner book? And I put it inside of the box here. And I ask you to close this box. Really careful, it's really important. Can people online show it? Maybe also people online?
Where's that?
Yeah, I think they just see it.
Oh, okay.
Yeah. And now I ask you to blow on the box and then shake it 3 times. The magic will happen.
Got it.
You want to guess what happened? What is inside of the box?
Yep.
There's the book. And that's amazing, because variables are boxes in our computer, and they're storing information. And that's what a variable is. It's about storing things, something that for us in the real world is so simple. It's just giving it, and we found the book again. In the digital world, it's amazing. It's something we can call magic. And as such, thank you, Arya, the goal and how you can see a variable, it's a box inside of our computer. So we put things inside, and we find them afterwards. Sorry a bit for those that were expecting, I don't know, a rabbit to come out of it. We're still a programming class. But the idea is that boxes are ways to store information inside of our computer. Variables, are ways to store information inside of our computer, just like boxes. So how do they work? First of all, you have to create the variable. So you go variable name equal hello world. If you cannot see it from far, it's not a problem. We're going to show it afterwards in the code. But what you do is you're telling the computer, please create a box, call it this way, and put something inside. So here in this case, could be create a box, call it Excode box, and put inside the book. And afterwards, when you need it, you just say print the name of the variable, and you get out the value of it. So as you can see here, we have print variable name, and the computer gets it out of the box and get back to us with hello world. What is also important to say is that, as you can see here, we have this symbol, which is only in this case and not here. Why? The reason for that is that in this case, it's string. So we use quotation marks to represent the string. While here, it's just a variable name, no quotation mark, because we are telling the computer, this is a variable, go check it out, and come back to me with the actual string. If you put the string here, want to guess what will happen? We'll just print variable name, literally just the text variable name, not understand that it's a box. So we've seen in Python, more often than not, we have a symbol that represents something. So here, do you remember what represent comments, for instance? What symbol do we use to represent comments? Who remembers? Yeah, that's great, hashtags. So that's what we do. For strings, for text, is a quotation mark. For variables, it's nothing. So if you just have some text, you know it's a variable. In Python, is as simple as it gets. The second property around variables is in the name, is that they can vary. That's one of their powers. So if I get something in the box, a value, I can then update it, new value. What I lose, obviously, is that I lose the previous value. But then when I get out of it, I will get the new value. Same thing as if I have my book inside, take it out, put in journal. When I get back, I have my journal. So 2 things about variables. They store information in our computer, and we can update them to have new information. So let's look at some code examples of variables. As always, you'll find all the explanations also in the lecture code. So if something's a bit unclear, you can just give it a read. It's similar to what I'm saying, but obviously written. So what I'm doing here is I'm creating a variable. Yes, and I'm calling it variable name. I'm using the equal operator to assign it. So when I create a variable, it's always the same syntax. Variable name equal something. In this case, hello world. If I run this, so click here, well, nothing happens because we're just, the things happen just behind. Nothing happens in our side. But what it's doing is the computer is remembering it. And then when I click print variable name, I get hello world. This is how it works. If I run only the second line before the first line, it will give an error because I've not created the box. We're going to see this as well. And then I can update it. If I say the same variable name equal to new text, then print it, I get new text. And I can do it indefinitely. I can do the same thing also for math. So we've seen last week, I have print 5 plus 5. It's going to give me 10. If I take a variable, here I'm calling a variable number, and I'm using the equal operator to assign it to 5 plus 5, so mathematical operation, and then I'm printing it, I get 10. What happens is the computer is reading this in order, as we've seen. It always starts from the start. So it starts in numbers, remembers, OK, I need to create a variable. Equal, so what is going to be this variable? 5 plus 5. So it does the sum automatically 10. And then it goes, oh, I need to print the variable. Let me go back, remember what it was. Oh, it was 10, and let me assign it. And let me return it to the user in this case, print it. Same thing here, another variable equal to 10.5. If I print it, I get 10.5. And I can also combine variables together, such as I can combine string. This is not a core focus. I'm adding it if you're interested, but I just add a plus, and it helps me combining strings, or I can also use a comma. So if I have my name is equal to Lorenzo, then print my name is plus my name. In order, creating a variable, calling it my name, assigning it to Lorenzo, and then print my name is my name. So if I run this, I can say my name is Lorenzo. And I can also have multiple variables together. So first variable hello, second variable word. If I print them together, I get hello world. And for instance, now we can use this to write a story and then change. So if I'm writing a really complex story that's like hundreds of pages, and then I realize, oh, wait, maybe my character name is not that fancy, and then I have to go and change it every single where. It's probably a big issue. So I'm going to assign it to a variable, so like my hero name or my villain name. Then when I run this, I get my story. But if I change it to like another name, you can see Luke faces John. That is arguably a bit more interesting name. I'll get the difference quite easily, and it saves me a lot of time. You can see here I have 3 variables. First, hero name, villain name. Then the third variable is story, which is a concatenation, means putting together both other variables and string. So I'm putting all of this together with pluses in between, and then I get the output, which is all of this next to each other. The next topic we're going to talk about is data types. And for this, I'm going to take the box again. So we've seen in the real world, we can put a book inside of our box. Simple. I can also put a journal like this. And maybe I can also put my computer. But here, my computer won't fit. So the way it works inside of in programming inside of computers is actually quite simple and quite good for us, because we have really defined data types. And all of these data types are of various categories, which make it simple. So we know what we are working with. Now we're going to see the principal ones. just asking you to sit and relax, not remember any of those, just kind of understand what are the main categories. The specifics will come later as you actually use them in the workshop. So the first one is the simplest. So what we're looking at is the various categories of data, so the types data can be stored. The first one is letters and words. We have characters and we have strings. So characters can be also seen simply as a string of length 1, so a single one. You see the age, the 7, the hashtag, and here, hello, 17, or hi. All of this, they count as letters word. Even though there's a number here, we can see that through the quotation marks, we have the computer will interpret this as a string. So the quotation mark are the symbol for strings, for text. Quite simple. Number 2, numbers. Numbers in Python are divided into 2 main categories, integers and floats. Quite simply, integers are whole numbers and floats are fractional, floating point numbers. We're going to see why this matters, but in the main reasoning you have to have is that on one side, I'm working with letters or words. On the other side, I'm working with numbers or floating point numbers. This is important because it changes how we work in code depending on what we're gonna use, and we're gonna see this in the examples. And then finally, we have Booleans. Booleans is more a look at this and then forget it, because the entirety of week 4 and some of week 5 is going to be around Booleans, because it's what defines modern computing logic. And Booleans are quite simple. They're either true, usually associated also with the value 1, or false, 0. They're one of the simplest way on paper, just true or false, but then they allow to make a lot of mathematical reasoning and complex reasoning that we see in programming languages. But at the moment, it's not the core focus, going to see them later on. And then finally, the last category is nullable. Nullable is all of those that kind of errors or mistakes. Let's see some of the examples. So null is representing no value. So if I ask, what's inside of the box? And there's nothing in the box, I get no. If undefined or undeclared is when I have not created the box, I have not defined the box. So I'm like, what's inside of the box? And there's no box. And then not a number is when I try to do mathematical reasoning, but that is impossible, like 0 divided by 0 or other things. This category is important because it helps you see errors. Because if you're working with variables and I try to access like the hero naming in your subway story and it says null, it means you have never actually assigned it to a value. Or if you say undeclared, it means you've never actually created that variable. Additionally, we can also inspect, so see the data type of a variable through the type built-in function. So we've seen a built-in function last week already. Can you remember what have we seen? As a reminder, a built-in function is something that Python provides for us that we call usually with the brackets. Do you remember what we've seen last week as an example of built-in function? Print. Yeah, all good. So we saw print. Type is just like print. So something that Python gives us free, and we can just use it in our code. Print, you give it some text, and what it puts out, we've seen, is the text put on the screen. Type, you give it a variable, and what it puts inside the variable data type. We don't care about how it works for now. We just care about the input, so type a variable, and the output is the data type. So if I put type hello, I get string. If I put type 17, I get integer. Type 17.5, I get float. This is how it works. Now, looking at some code. So these are 5 different variables. They're all assigned to different data type. So if I first run this, I am creating all of these variables. Then like here, I am printing them. So here I'm creating an integer and assigning it to 5, a float and assigning it to 3.5, a string and assigning it to a hello. And then we print this. If I have an undefined, it's going to give me an error. Name variable undefined is not defined. This is what we just said as I'm asking what's inside of the box. Here, I'm saying variable null is equal to known, so nothing inside, so it's just returning none. Here, these are Booleans, true, and it returns true. If I print 0 divided by 0, I get division by 0. It's not a number. It's not working as well. Then if I print hello plus 0, so try to concatenate two different data types, I also get an error, and we're going to see why. And now I can use the type operator to print what type all of these variables are. So if as you can see, let's look at the syntax first before running this. So this is the name of my variable. You can see, as we presented syntactically, variables are represented just by the name. So we have just the name of the variable. And then we use type to say, oh, what is the type? And we use print to print the type. So we will have 5 types, so integer, float, string, boolean, and null. And as you can see, it matches our actual types. So this is the theory, how it works. So what happens is I'm creating those variables, assigning them with the equal operator to something, either a number 5 or a floating 3.5 or hello, a string. Then I'm asking Python, what is the type of this variable? Please print it out. Python is saying, let me check. Oh, it's an integer, so I print type integer, or I print type string. It does not exactly like we will do in English, but it is quite similar. So now let's look at a simple program as an example. So let's say I have a website sign-up form, and I want to greet someone by name. Similarly to what you have on your platform. So on the Excode platform, when you log in, you have hi with your name, and then you can edit that out. Exactly like it works. So when you enter your name, it's creating a variable called name. It's equal to your name. And then when I need it, I just refer back to that variable. So I say print that variable. When you update it, I put the variable again. So here it's, if you look at the input processing output of such a program, the input is the user enters their name in a form or on a website or on Google Colab. The processing is we combine hello with the name. So we do string concatenation, what we just saw. So hello plus, and then the variable name. The string will have the quotation marks to represent that it's a string. The variable name is just a variable name. And then we get as output the sum of those two. That's put on a dashboard. That's put on your private email. That's put on Colab if needed. So this is how it usually works in Colab to get input. We use another, again, built-in function called input. We still have the brackets, as always, and then we have a string that represents the question. And so what happens here is that when I run this code, it's actually going to give me a line, and the user can enter the reply. So if I say name equal input, if here I write like Francesca, and then I do print name, I will get Francesca outputted. And we have other types of programs as well. So here we can see the one that we saw last week, so convert temperatures. Last week, we did it as simple as print. But then we have to edit the code every time. What we're going to do now is we're going to ask the user, what temperature do you want to convert? The user enters a value. We then process it, so we multiply it, and we add 32. And then we get as output a temperature in Fahrenheit. So rather than having a print thing where every single time you have to, do you remember all from last week? Or you had to do add the brackets as well and write that line. It was inside of a print statement. Here we're adding an input, creating a variable, and then outputting after the process. But let's see if you can spot the error here. If I do this, what will happen? Something will happen. Well, when I get the input, I am getting the input as text. Then in the processing, I'm actually doing multiplication. So try and multiply hello by 1.8. It's going to break. It's the same thing as saying, trying to put here inside this fits, but this won't fit inside of the same box. I need to convert it to a bigger box. This is how it works. I often can have problems where that's why we need to be so careful about data types, because I am taking something in a data type, like a string or some text, and then I want to do mathematical operation in it. So it's going to break. And that's why we have type conversion. So converting types to other types. For instance, here, we get our input is going to be a string, some text originally. Input is always text. Then we need to convert it to an integer. So I have a first step here. I'm going to convert it. I'm going to see how. And then I can do the processing. And then I need to convert again to a string to put it on the screen. And this is perfect because it also shows us two types of conversion. Here it is an explicit conversion. So we have to tell the computer, I want to change it from string to text, while here it's more implicit. Python will do it automatically. If we do print and then a number, it will automatically show it. We're going to see this now. So for explicit conversion, so when I actually want to convert, I use, again, built-in functions that will allow me to convert. They're quite simple. This is a lookup table. You can always refer to this or check online. If you have, like, here an integer, it's going to convert a variable to an integer. So let's say I have a variable, and it's x, and I want to convert it to an integer. I want to write int, the brackets, x, and then if I put here an example, if I put int 42, you can see here you have this is a string because of the quotation marks, and I get 42. Float, same reasoning, can also convert then from an integer to a string, because string 1, 2, 3, it's going to add this. And same thing, Boolean, they convert with 1 or 0. So bool 1 will get true, and bool 0 will get false. Is how they work. And we also have conventions for it. We're going to see the code now. So looking at those examples, getting a user input. Name, it's equal to input. What is your name? Good. Maybe Luke. So what is happening here is that it's first creating the variable name and assigning it to the input and asking me, what is your name? When I add Luke, it's going to actually go here and assign name as if exactly the same thing as saying name, it's equal to, this is the same thing as saying name, it's equal to Luke. It is exactly the same, but obviously it gives us the flexibility of saying just put whatever you want as user. Then thus, when I print it, I get Luke. Here in our conversion, if I do here Celsius input and I put 10, and then I print Celsius times 1.8 plus 32, it's going to give me an error. Can't multiply sequence that is non-int by type float. So when you have an error, don't panic. That's the first thing. The second thing is look at the 3 things you get in an error, which is the type. In this case, it's a type error. If you remember last week, we saw a syntax error. If I misspell something or a typo, I'm going to get a syntax error. And you know when there's a syntax error, you probably misspell something. If you have a type error, you know it's probably you put the wrong type. And then here, we get the explanation. So that's the second thing you need to look at. Can't multiply sequence by non-integer of type float. So for instance, here I can do this multiplication because I'm getting the 10. And then third thing I need to look at is where this error. So you're going to see here, it's at line 1, and it's here. So 3 things you need to look at when you have an error. What type of error it is, the explanation, and where it is. And so let's continue. Let's actually go and see how we can fix that up with type conversion. So when I key here, print type Celsius, it's a string. And that's why we need type conversion or casting. Usually casting is a synonym of type conversion for explicit conversion. There's not a big deal, just kind of semantically more than anything. So it's what we just saw, it's just integer, float, or string. So let's look at some examples. If I have, let's say I create a variable, A, and I assign it to 1, 2, 3 as string. And then I say, B, I want you to be the integer of A. So if I print the type of A, it's going to be a string because of the quotation marks. While if I print the type of B, it's going to be an integer because this told the computer, oh, go back, find A, and convert it from string to integer. Here, you are really lucky. In other programming languages, they are much, much more strict in how you set up variables. Other ones, you have to say explicitly every single time what type do you want your variable to be. In Python, it's the simplest thing possible. Regardless of your type, just put the name equal and the value, and then Python will understand what type your variable is based on if you have the curly brackets, if it's just a number, if it's written true, or something else. So then if I print them, they appear as the same. They appear to be the same to us, but under the hood, Python is storing them differently. So if I do print A plus 5, it's going to give me an error. But if I do print B plus 5, I get 128, which is correct. So what we need to do is convert Celsius to an integer. And then it will work. So here what we've done is Celsius, as taken as an input before, was a string. We've told the computer, we don't need it as a string. We need to convert it as a number, as an integer. And then when we try the same exact multiplication, it's going to actually give it, probably. And we can have possible and impossible conversions. There are some things we can convert, such as if I have here 4, 5, 6, and then string A, it's going to work. It's going to work because every number can become a text. I just add the brackets. But if I have a variable and I call it hello, then try to convert it to a number. What do you think will happen here? Who think it's going to be an error? You think it's going to be an error? Yes, it does. It's an error. I cannot have hello and convert it to a number. That's why I cannot do hello plus 5. And then we can also have implicit conversions, such as the computer doing the conversion for us. I'll leave this more of a further reading, as this is not something you need to know about, as the computer will literally just do this for us. But it means, for instance, in this case, if I have a is equal to 1, the type of a is going to be an integer. Then I do a is equal to a plus 2.5. A is going to become a float. And this is due to the fact that we're adding floating numbers to a whole number. It still works. It's just changing it for us. But as I say, this is not going to be required. It's not a big of a thing, as Python is doing it for us, and it usually won't create errors. This week, I wanted to also give you an example from a YouTuber called Primer. I don't know if you know it, but he does simulation on behavioral ecology and a bit simulated biology. And in this case, variables show us how important they can be in simulating environments. So I know in this case, we probably have 50, maybe 100 of different subjects and year, but regardless, variables are going to be used in every program you're going to take. In this case, for instance, in biology, we want to simulate the evolution of groups over time. We can have a variable that will store their birth chance or death chance or the population. And then I can have multiplication and addition and playing with those variables and simulate the evolution of ecosystems over time. And it's just a really nice example I wanted to give you from using variables to get things that apply to real-world fields and real-world simulations. So if for your thesis or for maybe PhD or for your dissertation or even just for your models, you have problems that require this type of problem solving, variables can be extremely useful in saving you time, in doing calculations, in predictive modeling, and much more. And you can see it's available on YouTube if you want to. So closing the lecture, I have 3 things for you. So first of all, a quick overview of the workshop. The workshop leaders will give it to you more in details, but just one quick thing. It's divided for this week and all further week. It's going to be divided into beginner, intermediate, and advanced. You only need to do the beginner section as like obligatory. We're expecting most of the STEM students to continue and do more, but as said, it's up to you how much you want to go. And usually beginner is exactly the thing that we saw during the lecture. Intermediate, it's those things during the lecture a bit more applied. And advanced, usually we have a couple more concepts or a couple more ideas. So just go and do as much as you're able to. There's no stress on that. Second thing, if you haven't already, maybe also later on join the WhatsApp group chat. And third thing, this week we are doing kind of a special research with Excode, a special activity. Just give me a second to explain it to you, please. So the way it's going to work is that we're experimenting new ways of teaching with Excode. And week 6 will be a bit of a different, an upgraded workshop. So not based on collab, a bit different. And for this, we need all of you to fill this. First of all, just kind of how it works. So how it's going to work is that you answer a couple of questions about yourself and a really quick personality. And after that, in week 6, we're going to get an upgraded workshop, and we're going to use that to make it better for you. It's really important to say a couple of things. So first one, we have ethical approval from the university. So it's a type of research we're doing to improve Excode over time. So if you want, the way it works is you scan this, you enter into this page, and you then can read how it works, how it's going to work. And then in week 6, you will be able to go and do this special workshop. It is a voluntary, so you don't have to if you don't. We obviously expect most of you to do it because we really recommend it. And we worked the entire summer on this thing, on preparing this. And the way it's going to work is that week 6, rather than having the regular collab workshop, you can have an upgraded one. A couple of important things from an ethical point of view as well is that it's entirely separate from everything. So the data is stored separately. It's entirely anonymous. And also, it's important to say that we're following all the guidelines. So we've worked with the university to make sure we follow all ethical guidelines. So we're going to now leave probably 5 or 10 minutes to fill this. And you're going to have up to next week also to do it. If you want to do it on your own time, I'm going to send an email of how this is going to work. So you want to just fill this, I'll leave you 5 or 10 minutes, and then I'll close this session. For the people online, I don't know if I told you, but you can do it as well, obviously. If 1/2 more minutes. And you will see your ID, and please keep that ID because you will need this in week 5 for the workshop. You can also enter your email, and the ID gets sent to you. We don't store the email; we just store the ID. So if you don't save the ID, we have no way of knowing and then associating with you. And also, please only do it once, not multiple times. So the way it's going to work is in the last week, we're going to have a special workshop based on this. By show of hand, are you all finished? Are you finished? You've done it? Shall I leave 1 more minute to finish? Who has not finished it and is still doing it? Okay, I'll leave 1 more minute. And then I'll give the code. Thank you all for filling this out. Make sure you save the ID. Please make sure you do. Please, but the better way is just put your email, then you'll receive it via email, or save it anyway, do a screenshot, do something like that. The code for this week, I'm going to give you in a second. First of all, I'm going to give a recap of this session. So this session, we saw 3 core concepts. Concept number 1 is variables. Variables are boxes inside of our computer. They work by storing information, and then they can vary. I can change information inside of a variable. The second concept we saw is data types. Inside of a variable, inside of a box, I can put plenty of things. And in Python and most programming languages, they are defined by types of data, principally the strings, the numbers, integer or floats, and then booleans and no. I can also use those by using the inputs or check what they are by using the type built-in functions. And finally, sometimes I have to change the data type, which I can do through type conversion, also called casting. And this can be done explicitly by saying this variable, please become an integer, or this variable, please become a string, or implicitly, automatically by Python for us. The code for this week is ex2mh. Let me write it here. If you need the code from last week as well, it's ex1bt. You can go on the platform app.excode.co.uk, go into week 2, write this code, ex2mh, write check-in, fill in the quick feedback form. If you have any feedback, we're going to read it and use it for next week. Maybe some concept that is unclear, we'll review it or send you some information about it. And then you're all set and you can go to your workshop. Thank you all for coming today, and I'll see you all next week.